Hello, good morning all. Welcome to next video tutorial on circular and doubly linked list. In the earlier concept, I have explained singly linked list and its operation. Then singly linked list with header node and its operation. Then different operations on singly linked list like searching for an item and concatenation. These are concepts we have studied in the previous classes. Today I'm going to start with the circular linked list, and this is the second chapter contain circular singly linked list along with its header node, then doubly linked list, then circular doubly linked list along with its header node operations, then how to represent a polynomial and performing evaluation and addition operations on it. Among that, the first bit is circular singly linked list. So what is the difference between just a singly linked list and circular singly linked list? In a singly linked list, what we are having, the last node always ends with a null character, and we start from the first variable. Here I have taken the first, which holds the address of the first node, but here we must make use of a last node representation. Okay, because the last node contains the address of the first node and it becomes a cycle. That is why it is called as a circular linked list. And advantages are every node is accessible from the given node. Like the last node contains the address of the first node, so each node can be accessible from the link field of all other nodes. Then certain operations like on circular linked list, such as concatenation and splitting, can be performed more efficiently. While solving the example, you'll come to know. And then how to create an empty list. It is same as that of singly linked list. Only difference is that earlier I am taking the first equal to null, but now I have to take the last equal to null. Okay, there first node, by using first node we are accessing all other element, but now we are making use of last node indication. Then by making use of last node, we are going to access creating an empty list like here. Just replace this name last is created, last equal to null, then only it is empty. Then creating a node is similar. We make use of an get node function. Whenever we call get node function, if the memory is available, the node will be created. If the memory is not available, that time we get out of memory output. Then uh, we have to perform the operations on circular singly linked list. It is same as that of the previous one. Here you have to perform the same operations like inserting from the front end as well as rear end, deleting from the front end as well as rear end, then display the content of an list. In all the operations, these five operations are fixed one. Okay, at the first one, inserting a node from the front end. Okay, this is the existing circular linked list. I want to insert the new node temp at the beginning, or you can say from the front end. The first step remains same, like we have to create the temporary node by using get node function and assigning the name is temp, then insert an item into it where in the information field temp pointer info is 50 are inserted. What is the next step? Earlier in the given existing linked list, the last pointer link is connected to where the first node. Now after inserting the temp node, this becomes the first node, so I have to provide the link from here to where last node to the temp node. Then this one is not connected. We have to connect this also. Okay. So step two, obtain the address of the first node if the list is not empty. So how to get it? If last is not equal to null. So earlier what we are using without using circular linked list, if first is not equal to null, indicate that empty list. But now if last is not equal to null, that time it becomes uh, not an empty list. Okay. Then uh, last pointer link. This last pointer link will be assigned to where? Assigned to temp pointer link. Means that last pointer link now will be given to the temp pointer link. Okay, it means that we just provide the connection from this last node value will be given to the first node. Else temp is last. If the list is empty, then whatever the node I'm adding, that will be given to the temp node. Okay. Then make temp as the first node. That is, this node become the first node now. So last pointer link equal to temp. So this last pointer link will change from last pointer here to last pointer temp. Now this becomes the first node. Then at the end again you have to return last. Okay, earlier in the single linked list just we are using return first, but here we have to return last. Okay, then write all the four steps in the given function. Node insert, circular linked list, front, int item, node last. Item we are inserting, earlier we were taking node first, now I will take the node last. Insert, next operation is insert a node from the rear end of a circular linked list. LL indicates linked list. And then what is the difference now? This one, what is existing, I'm going to insert the temp node at the end. Then this node, earlier the last node connected to the first node, but this node uh, is not last node. Now whatever the temp I am going to add, that becomes the last node. So that this link has been removed. In that place, temp pointer link contain the address of the first node that you have to perform. Then this link is not there, you have to specify last pointer link is temp. Okay, so copy the last pointer link address to temp pointer link if list exists. If last not equal to null means the list is not empty. Then last pointer link, you want to wear the temp pointer link. Then this link is removed, this link is provided. Here I mentioned the step 2. This indicates step 2. So this link is provided here. Then next third step is providing the link from last pointer link equal to temp. So last, make the temp as last node. So last pointer link is temp as in third step. Then return temp, because the last node earlier what we return last, but last node is temp now. So return temp. Write all these four steps inside this function. Okay. Then delete a node from the front end. I'm going to delete from the node from the front end. For that again you have to check for all the cases. Case 1, if list is empty. As I told, if last equal to null, list is empty, return null. Case 2, if the list contain only one element, that time only one element is there, that is the last one. Last pointer link again contain address of same node, it indicates that only one node is there. Then delete last pointer info, 10 will be deleted. Free last, this last node will be deleted, freed. Then return null, so this will be obtained. This is before delete, this one is after delete. Then third case is that list contain more than one element. So this is the list, existing list contain more than one element. So delete from the front end, so this node need to be delete. Then if this node is deleted, what has to perform? Earlier the link exists from last to first has to be removed, and in that place we have to provide the link from last to the this 20th, become this becomes the first node now after deleting this. Then how to implement this? First node is assigned with the name first. First equal to last pointer link. Here this first is not, this will be assigned as first now. First equal to last pointer link. Here I specify the name here. For the node I'm taking to copy the address, first equal to last pointer link. Then now make the second node as the first. This becomes second node as the first now. For that, what you have to perform? Last pointer link equal to first pointer link. Last pointer link is this one, and first pointer link is this. This becomes the first node now. Then delete this. Uh, Remove the first one. Delete the item equal to percentage d first pointer info free first. Then this node has been deleted. This one is deleted. Then display the last node. Then write all the four steps inside the function. Okay. Then the last one, delete from the rear end. Earlier we deleted from the front end, now I'm going to delete from the rear end. So if I delete this last node, I need the previous also. Why? Because if I delete this last node, this link is last pointer link contains the address of the first node. I have to remove that, and I have to provide to where? I have to provide that link to here for the previous node. So if I'm taking this as the previous node, then I need the initial value also. Obtain the address of first node. How to obtain the address of first node? This becomes the first node. For that, I have taken the last pointer link. Always give the address of first node. Now I'm taking it as a previous one. It is circular queue. That is why circular linked list. So that if I consider this one is the last, this becomes the previous one. So previous equal to last pointer link. Okay, then find the address of last but one node. So last but one node I have to get. If I start from previous pointer link up to where to check, up to last. Earlier in single linked list we are taking up to null value, but here we have to consider up to the last value. Okay, while previous pointer link not equal to last, previous equal to previous pointer link, we keep on increment the value. Earlier we'll get this address. Once we get the last address, then we have to delete that. Print delete last pointer info free of last, then make last but one node is the last node. So previous pointer link, this link is removed. Previous pointer link will be added to where? The first node. Like previous pointer link is equal to last pointer link. Last pointer link followed by the previous only. Okay, then these all return last. These all four steps to be stored inside the function. Then display like first check that list is empty or not. I'm taking the temp equal to last pointer length, means that it will come to, if I'm taking temp, I'm taking the variable name temp here. Temp equal to last pointer length. So this is temp will hold the first node, then display the information. Then temp not equal to last, yes, true. Printf temp pointer information, the 20 will be displayed. Then again temp equal to temp pointer link until it reaches to last. Will keep on visit all the nodes, then display the values. Once it reaches to the last node value has to be displayed separately because it already contains the address of first node. So display that last value also. Printf percentage %d temp pointer information. This statement for displaying the last node. Okay, the next video tutorial I'm going to explain uh, circular linked list with the header node. Let's go through the video. In the introduction class I'm going to solve the queries.